In the activity above, Ms. Garcia took you through the process of taking the slope and the y-intercept and writing the equation or pulling it out. Now we're going to show you how you can take that equation and do it from a graph. So you say, what do you mean do it from a graph? Well, we learned in the last activity that a linear equation can be written as y equals mx plus b, where m is the slope and b is the y-intercept. So I need to find those two things. So the first thing I'm going to do is I'm going to find the y-intercept, because to me that's like the easiest part, because I see that this is the y-axis, and I'm going to say, where does this blue line cross the y-axis? And I say, oh, it's right here at the point 0, 2, because it doesn't move left to right, it just goes up 2. So the point is 0, 2, but for my b, I'm just going to need that 2. That's my y-intercept. Now I need to find the slope. The slope, when we have it from a line, we've already learned in past activities that all I need to do is find 2 points and create a triangle, a right triangle to be precise. Mr. Nelson went over this with you, from there. And so, again, I'm going to see that it runs 1 and it rises 1, 2, 3, 4. See, even I can make mistakes. So it rises 4, it runs 1. It's the change in y over the change in x. It gives us our slope, so it's going to be 4 over 1. And 4 over 1 can be simplified to 4. Now remember, let's just quickly check. Positive, negative, no slope, 0. Well, this is positive, and that's positive, so we're good. Okay, now that I have those two things that we've learned how to find in previous activities, all we're doing is we're putting it together. We're saying, okay, y stays y, but I know m equals 4, so I'm going to substitute m with what it equals. It's a 4. X stays the same. Plus b. B in this case is the y-intercept, which is 2. And I want you to stop for a second and think about this. We just took a line, a visual representation, and put it into an equation, a numerical equation that represents something that we saw on the graph. That's pretty amazing. So let's go ahead and try another one, shall we? I want you to pause, try it yourself. Okay, I'm going to assume you did. So again, we're trying to get an equation into y equals mx plus b. That's slope-intercept form, because you have to find two things, the slope and the intercept, which is the b. It's known as the y-intercept. So let's find the y-intercept first, because I know that's the easiest for me. I look and here's my red line. I see that it crosses the x-axis right there. That's at the point 0, 1, 2, 3. So my y-intercept is going to be 3, because as Ms. Garcia said, the y-intercept is always going to be the y part of the ordered pair. So now I have that. Now I need to find 2 points and make the slope. And we've done this in past videos. So again, I'm going to just look at the graph, and I'm going to make a right triangle. I always like to make it underneath it. And the reason why I like to do it underneath it is because this way the rise is always above the run. So again, I see that it goes 1, 2, 3, 4. And this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Yes or no? But hold on. Remember that we had to go to the left in order to do this. So this would actually go negative, because my point went to the left to get there. How do we verify this? Positive, negative, no slope, 0. This is not a positive, but a negative. If you hate singing, I would recommend every time write the house's slope build, because then you can really quickly say, okay, what does this match? That matches this side, so this should be negative. That makes sense that this would be negative. So it's rise over 1, run, the change in y over the change of x. I get 4 over negative 12. I can simplify that, right? I can divide them both by 4. That will give me 1/3, and I'm going to put that negative out front. So you can put it on the bottom, the top, but usually you just put it out front. So now I have the slope, and I have the y-intercept. I have my equation. I'm going to drop this down here and say y equals m, which we now know is negative 1/3, which makes sense because our slope is negative, x, don't forget that x, a lot of kids forget the x, plus 3. So this equation represents the line you're seeing on the board. It's pretty cool. All right, let's try another one. Okay, I'm assuming you did it. So here we go. Again, y equals mx plus b, and I need to find the slope and the y-intercept, which is also known as b. So my y-intercept is where this red line crosses the y-axis, and that crosses right here. I'll put it as green at the point 0, 2. So my y-intercept should be 0, 2, which means my b is going to be 2. Because it's where that y value of that point. So I know what b is. Next, the slope. Now I can do a triangle, but guess what? We've learned the song: positive, negative, no slope, 0. Or if you're on the top of your page, you've written this down, which you should do every time. Just on the top of your page, just leave it there. I know that, oh, this slope is 0. That means that my slope here is 0, right? Now, I put it into my equation. Y equals m, which we're substituting with the value 0. I always got to put the x. Don't forget your x. Plus my y-intercept, which is 2. I have that equation down, but like Ms. Garcia said last time, nobody's going to leave 0x, because 0 times anything is 0. So I could write y equals 0 plus 2, but that just looks silly. And then 0 plus 2 is just 2, so we just end up with y equals 2. And believe it or not, this is in slope-intercept form. All right, let's have you try another one. Oh, snap. Go ahead and try it. So, y equals mx plus b is my equation. I need to find m, and I need to find b. And so I go, okay, let's start with the y-intercept. But I look over at my y-intercept, and guess what? Does this touch the y-intercept? No, it doesn't. So guess what? There is no intercept. Or I could put non-applicable, NA. All right, that's fine, it's fine. Let's just do the slope then. Oh, well, I can't do a right triangle because this is positive, negative. This is a no slope, right? If we did the house that slope built, positive, negative, no slope, 0. This is a no slope. So wait a second, no slope. Well, crap, I can't put no slope. I'm not going to substitute no slope in for m. I'm not going to put in no intercept for b, because if I put in 0 there, 0 means that the intercept is 0. So I'm in this weird quandary. This ends up where we're going to get special cases from. Well, let's take a look at this graph. Is this a function? It's not. But I have a bunch of points, and we'll just pick some obvious points. There's points all over the place. That's what makes the line. But let's pick some points. So if I look at this point here, this is the point 1, 2, 3, 4, negative 2. So I have 4, negative 2. Here I have 4, 0. Here I have 4, 1. Here I have 4, 2. Here I have 4, 3. Here I have 4, 5, and so on and so forth. Well, what's the one thing that repeats? 4. The 4. And so the only thing that repeats is the 4. Is 4 x or y? It's x. And so this is a special case. Whenever you have a no slope, because you can't have a slope, and it may not even touch the y-axis, we have to do something different here. What we do is we write x equals, and what does x equal in every case? 4. And that kind of makes sense. It's just saying when I go to the 4 on x, anything on there is an answer for it. And we're going to spend more time on that later.